So for theorem 10.7 and 10.8, we actually put them together in what's called a 2 out of 3 rule. The idea being that if any two of these three things are true about chords, then automatically we know that the third will be true as well. Now, beyond just knowing that that third statement is also true, we can additionally say that we have some arcs that get bisected. Now, it's a little bit weird just to talk about, so let's take a look at an example and see how this theorem applies. If I look at example number 1, it asks, is there enough information to say that triangle BEF is a right triangle? So right off the bat, I see that triangle BEF is this triangle right here. If I want to show that this is a right triangle, I need to show that angle BFE, this one right here, is a 90-degree angle. This is where theorem 10.7, 10.8 comes in. If I look at my diagram, I see that CB is a chord, DE is also a chord, but there's something a little bit more specific about CB. CB is a chord that passes through the center of my circle, this point A, so it's not just a chord, it's actually a diameter. So we know that CB is a diameter. If I keep looking at this diagram, I also see that this chord DE is bisected by chord CB because DF is congruent to FE. So we can say that DE is bisected because DF is congruent to FE. So if we look at our list of statements, we've now shown that one of the chords is a diameter. We know that one of the chord bisects the other. So by theorem 10.7, 10.8, we actually know that these chords are perpendicular. So by theorem 10.7-10.8, the chords are perpendicular. That tells me then that these four angles are actually 90 degrees. So triangle BEF is a right triangle. Now let's take a look at another example of a different case. If we look at example number 2, it says determine the value of x. Now note that x is going to be part of this arc BE, where we know that BE is 7x plus 10. We know that this arc BF is 45 degrees. If we want to go about this problem, this is also an application of theorem 10.7, 10.8. If I look at this, I'd no longer know that this chord CB is a diameter because it's not showing that it's going through the center of our circle. However, if we look at it, one thing that I notice is that they are perpendicular. So I can say that CB and EF are perpendicular. That's just something that's given to us by that 90-degree angle. We also know that that chord EF is bisected because DF is congruent to DE. So if I look at what we can show, and I look back at theorem 10.7, 10.8, we know that the one chord bisects another. We also know that the chords are perpendicular. Therefore, by theorem 10.7, 10.8, we know that actually that chord CB is a diameter, but additionally, we know that the arcs are bisected. So if I look at this problem, so by theorem 10.7-10.8, CB is a diameter and FE, the arc, is bisected. Now, because we know that that arc is bisected, we actually know that BF is the same as BE. So I'm going to mark that in my diagram. And if we know that these are the same, that means that we could say something like 45 degrees is the same as 7x plus 10 degrees. And this is a two-step equation now. If we want to solve for x, I can subtract by 10 on both sides. That gives me 35 is equal to 7x. X on its own side, I'm going to divide both sides by 7. Tells me that x equals to 5. So that is another application of this theorem 10.7, 10.8. Our last example, if we look at this diagram, we're told given FD equals to 12 and DE equals to 3x, determine the value of x. So as I start to look at my diagram, I again notice that this chord CB passes through my center at A, therefore CB is a diameter. I also notice that I have a 90-degree angle right here, so I know that the chords are perpendicular. Now, looking back at my list of statements, we know that one of the chords is a diameter. We also know that the chords are perpendicular, so automatically we know that one of the chords gets bisected. So, by Theorem 10.7-10.8, we know FD is congruent to DE because EF is bisected. Now, also note, again, we would know that FB, the arc, is congruent to BE, the arc, as a part of Theorem 10.7, 10.8. Doesn't really apply to this problem, so I'm not going to write that down. But if we want to solve this now, we know that FD must be the same as DE, so I can set 12 equal to 3x, and solving for x, I can just divide both sides by 3 to say that x equals to 4.